Hello and welcome to the second section of Mastering TypeScript, Deploying the Type System. In the previous section, we introduced the sample application. In this section, we're going to look at using the type system. Our first video will be on avoiding the AnyType. Second video on how to use implicit or explicit types. Third on being aware of how TypeScript uses structural typing. Fourth on composing types. So essentially combining multiple types together into one type. Fifth, at the object type with a lowercase o. That's not to be confused with the object type that has an uppercase o. Then at literal types, then map types, the never type, and our last video will be on representing data objects. In this video, we're going to look at one of the most important steps you can do to help write better TypeScript code, and that's avoiding the AnyType. We'll look at why we should avoid it, and then at some language features we can use to help avoid it. So first of all, what is the AnyType? The AnyType is essentially a way to opt out of type checking. It allows us to use a value in any way that is syntactically correct. So why should we avoid it? Using the AnyType opens us up to all kinds of problems that we used to experience with JavaScript. We'll lose static type checking and the ability to refactor our code. Here we have a variable, food item storage, which we can use for getting food items out of the database. Right now it's typed as the food item storage class, but if we explicitly type this as any, the compiler will now let us use this variable in any way we like. We could write food item storage.myNonExistent function, and we won't get a compile error, but we will surely get a runtime error saying that this function doesn't exist. Essentially, by using the AnyType, we have lost our friend the compiler, who helps keep us in check. To avoid the AnyType, values should be described with types. But what happens if we want to have a value that could be one or more types? What should we do then? Here in Number Helper, we have a function that we want to take a number or a string. In the case that it's a number, it will convert it to a string. When it's a string, it will leave it as is if it's a valid number string, or otherwise return an empty string. In the case of it being neither a number or a string, it will throw an error saying so. In most languages with a type system, we wouldn't be able to accurately describe that to the caller, and we'd probably use something equivalent to this current code, where the function could essentially expect any kind of type, and then throw an exception when the value doesn't equal any of the expected types. Doing this is a pain. Luckily, TypeScript has a concept of union types. Union types are a way to say that an object could possibly be one of several types. Let's go ahead and accurately describe the expected input types of these functions for the callers. So remember, we want this toString function to accept a number or a string. To do that, we can write string, then put a vertical bar, then write number. Now we can see this value could be either a string or a number. And within these if statements, the value of val is typed as number here and string here. It's typed this way within the if statements because the compiler is smart enough to figure out the types at these points in the code based on how we've checked for the type in the if statement. One huge benefit this brings is that we don't need to throw an error when this is used incorrectly anymore, and we can remove this additional check for a string because we know that if this first check for a number fails, then the value must be a string. Doing this means that we are now relying on the compiler to catch the incorrect use of this function at compile time, rather than runtime, as we would have previously had to do in JavaScript. Note that in certain situations, you may want to keep the additional checks and throw. For example, if you're developing an API that might be used by JavaScript developers. In this case, this code is internal to our project, and the added code isn't worth being maintained. In this video, we looked at why we should avoid the AnyType. We also saw a way of avoiding it by using union types. Overall, sometimes using the AnyType can't be avoided, and in certain scenarios it makes sense to use it. When you can, I would encourage you to avoid using it, or at least limit its exposure in your application.